Okay, welcome back to the 3-6 notes. Let's take a look at number 15. And this is a standard problem that you guys would see in like Algebra 2 and pre-calc. And you're talking about, something thrown vertically. Okay, and so, they give you all this information about, what's happening and, how fast you're throwing it and where you're throwing it from. And then it says the height S in feet, okay? And so when I see that, I know that this is a function s, and that is my y-axis, okay? And I'm going to label that as over here on this graph. Come over here, and I'm going to label this feet, okay? This is my height in feet, okay? And so then... okay, as we read this, it says, the height s in feet of the stone above the ground, t seconds after it is thrown is this function s. Okay, so my x-axis is t, is time, okay, in seconds. So I'm going to label this axis as time in seconds, okay? And so it's important, guys, that's the big thing about this, is actually labeling your axes and knowing what the situation is, okay? That will help when we're trying to find, answer other questions about velocity and acceleration and stuff like that. So then, okay, so part A says determine the velocity v of the stone after t seconds, okay? That just says use this function s here and find the velocity, okay? So what we know is that if I take... my function s, and this is part A, if I take s is equal to negative 16t squared plus 64t plus 32, what we end up getting, if we wanted to find the velocity, we just take its derivative, okay? And so then I would say this, s prime, which is the same thing as saying ds dt, okay, is equal to the velocity v, which is equal to negative 32t plus 64, okay? So, that's all we need for part A, okay? That's our answer. Just find the velocity, take the derivative, okay? Part B asks, when does the stone reach its highest point, okay? And that's another way in part B of saying, what's the maximum height, okay? So what's the max height? Max height. And so, this is a quadratic, guys. You could, that's when you let t equal, opposite b over 2a, and then in order to find the actual height, you just plug it in and find s of negative b over 2a, okay? And so, you could do that using this quadratic. I've just gone ahead and graphed it for you just to save some time. And what we notice here is that we have a maximum height at 2, and that's 96 feet. So after 2 seconds, the maximum height is at 96. So let's just go ahead and write that down. We could do that algebraically, but I just want to save some time. So when does it reach its highest point? So that's at t equals 2 seconds. Okay? That's the answer for B. The answer, part C, says... what is the height of the stone at its highest point? And so part C, we would say that that's at 96 feet. Okay. All right, and then it asks, when does the stone strike the ground? Okay, again, what you could do for this is you could solve this algebraically. You would set your function s equal to 0. So in part D, not part B, you would write 0 is equal to negative 16t squared plus 64t and then plus 32. And you could solve this by using the quadratic formula. You could probably factor it. I'm just, in terms of our time right now, I just want to, show it to you graphically. So if we zoom in here, we notice that happens. The stone hits the ground at 4.449 seconds. Okay, that's that point right here. That's the x value or the time value. Okay, and that's when we have a height of 0. Okay, when does it hit the ground? Well, the height off the ground is 0 feet. So let's go ahead and go back, and in part D, let's just write at time 4.449 seconds. Okay, 4.5 seconds. Okay, and then it asks in part E, well, with what velocity does the stone strike the ground? And so you'd plug this time value, okay, into your velocity function here, and then you'd evaluate it. So let's just go ahead and do that in part E. All right, I would use V of 4.449, and that's going to be negative 32 times 4.449, and then plus 64. Okay, so then plus 64. And I've gone ahead and already evaluated that here. And so I took the, if you want to see what's going on in this picture, we've got our function here. All right. We have table of values of that function. So here's that, here's time, here's the height. Here was what's happening 2 seconds, and we had a height of 96. And this is where it hit the ground, right about here. And then, here's that x value, and here's the, the derivative value. Okay, these are the different speeds that it's traveling. So it's traveling at, negative 78.368, and that's in feet per second. So let's go ahead and write that. Let's write negative 78.368, and that's in feet per second. Okay, so that's the velocity at that time. All right, let's go ahead and take a look at the last one. It says, on what intervals is the speed increasing? So, and we've been talking about this, about how, looking at the graph, okay, you can think about the speed increasing, but you have to kind of think of this in terms of, what you're doing. Okay, when you throw that object, when you throw that stone up in the air, then the speed is actually decreasing. Okay, gravity is pushing down on that, and you've got an upwards velocity. And since those, don't match, it slows it down, hits a maximum height, and then it starts to speed up from here to when it hits the ground. Okay, and so that's from 2 seconds to 4.49 seconds. Okay, so let's go ahead and write that for part for part F. Okay, it's the speeding up at or from 2 seconds to 4.449 seconds. Okay, so that's all I got for that one. Let's take a look at the next one. Okay, that's the end. All right. Okay, let's take a look at problem number 24. And this is a question about velocity in a car. And so it says the graph shows the position function s equals f of t, okay, of a car t hours after 5 p.m. relative to its starting point s equals 0, where s is measured in miles. Okay, so all this is showing how far this car travels over a time period, okay, over a 2-hour time period. And so, our x-axis is time in hours, y-axis is position in miles. Okay, so we'll be using these labels on the graph to help us answer some questions here in a minute. Okay, but let's take a look at part A. Part A is, it says describe the velocity of the car. Specifically, when is it speeding up and when is it slowing down? Okay, so on this, it's kind of hard to read on a graph like this, but you have to look to see where are we increasing faster. Okay, this is position in miles. So that's, wondering where are we speeding up and where are we slowing down. We want to look at when is the graph kind of going up, like concave up. Okay, we want to look at that. And so when it's concave up here and here and here, we're getting faster, we're going at a faster rate, and then all of a sudden right here we start to kind of decrease a little bit. All right, we're not going as fast longer, and then all of a sudden we start to speed back up again. All right, so let's take a look at that, and let's answer that question in part A. And so part A, we would say, when are we speeding up? So we're speeding up, so we speed up, and let's take a look at those intervals. It looks like from about 0 hours to 1.5 hours, it looks like we're speeding up. It looks like we're concave up, okay? We're increasing faster. And so then I'm going to go ahead and say that that's from 0 to 0.5 hours, okay? And then we're speeding up from about 1.25 hours up to 2 hours, okay? That's where, again, we look like we are concave up. All right, so I'm going to write that. So from 1.25 hours to 2 hours. Okay, and then we slow down, okay, over the other interval where it looks like we're, kind of concave down, okay? And so that's just when the graph kind of looks like it's, going down. So let's write that interval, and that's from 0.5 to 1.25. Okay. All right, let's take a look at part B. Part B says, at approximately what time is the car traveling the fastest? When is it traveling the slowest? Okay, so I really want to look at my tangent line on that. So, let's take a look at part B. I'm thinking about where could I draw the steepest tangent line? And that's right about here. And I'd say that that's at, about 0.5 hours. So we're traveling the fastest, okay, at let me write at t equals 0.5 hours. Okay, so at t equals 0.5 hours. Okay, and then it asks when are we traveling the slowest? Okay, and that would be probably around 1.25 hours, right here where we're probably the steepest, and probably at time 0.2 is when we're traveling the slowest. And you could probably make an argument at 2 hours that we're going faster as well. So let's also, in addition to saying t equals 0.5 hours, I'm going to say t equals 2 hours as well. Okay, and it's traveling the slowest. Okay, that's at time t equals 0 hours. Okay, and then at t equals 1.25 hours. Okay, so I'm really just looking at the graph to try and answer that question. Okay, and then it says, what is the approximate maximum velocity of the car? Okay, what is the approximate minimum velocity? So what I'm going to do in this on part C is I'm going to draw a tangent line here and try and see if I can get some points from that tangent line. And so what I notice here on this one is that I've got a point here and a point here. And so I'm going to calculate the slope of that line. So I'm going to find the slope is, what is this, 1.125? So that's the point 1.125, or no, I'm sorry, not 125. 1.25. 1.25, and that's 50. Okay, and this is the point 0, 0. All right, so with that, I've got the slope of 50 minus 0 divided by 1.25 minus 0. Okay, so we get 50 divided by 1.25, which is 40. Okay, and that's in miles per hour. Okay, so we'll put a label on that. And then it wants us to find when do we have the minimum velocity. Okay, when do we have the smallest velocity? And so that's going to be, right at, right here at 1.25, the slope of this line. So let me draw a slope on that part, and I'm going to make that brown. And try and just get a couple values here. And all I'm trying to do, guys, is to, you know, find some locations on that line that I draw, okay, that are pretty reasonable. And so this is the point 245, and this is the point 035, okay? And so let's calculate the slope on those points. And so that's 45 minus 35 divided by 2 minus 0. And so that's, 10 over 2. And that simplifies to 5 miles per 1 hour. Okay. So I hope you enjoyed this video. I hope this helps out. Again, guys, I'm just using, my knowledge of these functions and, just thinking about it logically to answer them. So please continue working on your homework, and we'll see you soon. Thanks.